We often need to think about the reason that we would want to integrate something. If we know what the gradient function is, then if we integrate it, we could find the actual function itself. Or if we know what the second derivative is, we could find the first derivative, and so on. But we can't find it unless we have a clue. And that's because when we integrate, we end up with that plus c on the end. We have something that's unknown, so we need a clue so that we can figure out what the c part might be. So here's an example of a question that you might get. We know that the first derivative of something is e to the power of x. And we have a clue here that the function of 1 is 0. So we need to find f of x. So the first thing to do is to say, well, let's find an equation for f of x. In other words, we need to integrate this one and come up with something. Now, integrating e to the power of x gives us e to the power of x, but importantly, we also need plus c here. Now we can use our clue. The function of 1 is 0. What that means is that if I sub 1 in here for x, I'm going to get 0. So let's go ahead and do that. If I find the function of 1, then I've got e to the power of 1 plus c. That has to equal 0. So then what's c? Well, let's solve this for c. We need to subtract e from both sides, so we'll have minus e. What do we do now with our c? We sub it back in here. So instead of writing this as a bit of an embarrassing unknown, we can say, look, we've found out what it is now. We can actually write the function properly. It's e to the x minus e. I could have added negative e, but I think it's neater to just write minus e. And this now is our function. Now to check your answer, if you want to, you can check whether it's true. So if we differentiated this, would we get that? Yeah, we would. This part would differentiate like this, and this is just a constant, so we'd leave that out. And is the function of 1 here 0? Well, if I sub in 1, I'll get e to the power of 1, and e minus e is 0. So yeah, it seems right.